Okay, so we're going to work through section 8.1.5. I'm going to guide you through that today. So, the focus of this investigation is to learn some factoring shortcuts. Like, do we always have to make the generic rectangle and the diamond, or are there some patterns that we can actually kind of find? So, the first thing I want you to do is to I attach this as a paper. So you could either like print it out if you have it at home, okay, or if you don't have a printer at home, you could just write these different expressions on just a sheet of paper or little note cards or something. So what I'm going to ask you to do is you're going to try and factor these. Now, the lesson was sort of intended to like divvy these up with your team and have some kids do some and then sort of pull them together. So I'm not going to ask you to do all of them unless you're completely bored at home and want to do that. You could factor each and every one and for practice, but maybe just pick 2 or 3 different ones, maybe 4 that you want to try and factor. So again, you're going to take, like, let's say you decide to do this one right here. You're going to make your generic rectangle. You're going to do 4x squared minus 25. Product of those two things is negative 100 x squared. And sum is 0. There's not a b term. So negative 10x and 10x would be our two sides. Bring those over. 10x. And so I get 2x, 2x minus 5 and 5. So this one factors into 2x minus 5 and 2x plus 5. Oops, I went off the screen. Okay, so I'll give you a minute to try and do a couple of those. Okay, you just pick a few. Okay, so if you didn't do all of them, okay, and just picked a few, go ahead and fill in the other ones. So I'll give you a minute to go ahead and just write in the other ones on your sheet of paper that theoretically your team would have brought together and done, but so I'm just giving it for you. And then you're going to cut these into strips. Okay, and the goal is to try and hunt for some potential patterns. Okay, so after you have them cut into strips, you're going to try and put them into some different categories of some similar things that you find, okay? So, and give you a little hint, you can probably fit it into 4 categories. There are 3 sort of recognizable patterns and then 1 sort of misfit. Can you guess which one's the misfit already? Okay, so hopefully you found the misfit was K, okay, because that one doesn't factor. Okay, so that just kind of goes on its own. All right, and let's go ahead and look at one group should have a heading of A. Okay, so see if you can find the other ones that went with your A. Okay, did you have F, L, and H? Did you put these all together? Did you notice they had kind of a pattern that you can see between them? So if you look kind of at the way it factors, well, 1, the B value was missing. You see that? The BX value. And when you factor it, it factors into like the two factors are pretty closely related, but one has a subtraction sign and one has an addition sign, but otherwise they're just identical. Okay, so this factoring shortcut, okay, is when you see the difference of 2 squares, okay? So in order for this factoring shortcut to work, both of these have to be perfect squares and there has to be a subtraction. So like for instance, this would be another one that would fit that pattern. So say I have 36x squared and I subtracted 100. Okay, what do you think that's going to factor into without even doing the whole generic rectangle and all of that? Can you get it in factored form? Okay, did you think it would be 6x minus 10 and 6x plus 10? Okay, but notice how that one wasn't completely factored from kind of an earlier lesson, that they actually have a factor kind of hiding inside. Okay, so we really probably could have also factored out a factor of, let's see, of 4, 2 from each of these to make it smaller. So maybe that wasn't the easiest example to see one factored completely. Okay, let's look at, let's say I had 49x squared minus, let's see, how about 16? Can you see what that would factor into? Okay, did you think 7x minus 4 and 7x plus 4? Okay, so if you see two perfect squares and a subtraction, you can easily factor it with all that extra work. Okay, now I probably shouldn't have given this one as an example, but it'll give me a chance to sort of review about factoring completely. What is the common factor in both of these things that we should have looked for first? Okay, 36 and 100, do you think 4? Okay, so that will give me 9x squared minus 25. And now I've got perfect squares here. So if I want this factor completely, this would be 4 times 3x minus 5. And perfect square, and 3x plus 5. Okay, so I took out that sort of lurking factor of 2 from each of those and got the 4 here. Okay, so difference of two squares. But that goes, I'm glad I kind of did that because that reminds me to think about, if it's not factored completely, and you'll be asked on that on the quiz tomorrow, look for a greatest common factor first, pull that out, and then make it smaller. Okay, so difference of two squares. Okay. All right, did you see another sort of special pattern? Okay. I tell you that those go with the ones that start with C. So did you see any other ones like C? Okay, did you say D, G? Oops. And J. Oops. Oh, yeah, sorry, it was G. Ding dong. Okay. All right, so did you find these to have the same factoring pattern or similar factoring pattern? What you maybe noticed is that these two factors were actually identical, okay? So, and actually on all of these, we could have written this as x minus 5 squared. This one we could have written as 3x plus 2 squared. Okay, so these would all be equivalent to each other. Okay, and same with this one. We could have made this equal 2x plus 5 squared. And this one we could have called x minus 3 squared. Okay, so this is a factoring pattern. This one's a little harder to see than the difference of two squares. Okay, these are actually called perfect square trinomials. Okay, so because when you factor them, the factor turns into a perfect square. It factors into x minus 5, x minus 5. So both the sides end up being the same. Okay, now these are a little bit harder though to recognize that that's going to have that factoring pattern. So let's kind of look at those again. Okay, so did you see anything that was sort of special about these? Okay, well, you might have noticed that the first, the ax squared term, it's a perfect square. So that's one way that you can kind of hunt for these. And the c term is also a perfect square. Okay, but just those being a perfect square is not enough. Okay, so something special actually has to happen with this middle term. Okay, so see if you can think how that's related to these two perfect squares. Okay, so how does the negative 10x come from the square root of x squared being x and the square root of 25 being 5, or actually negative 5? Okay, so did you see it? Let's see. So let's look at that x squared minus 10x plus 25. Okay, so x minus 5, x minus 5. So the x's give us the x squared, the minus 5x and the minus 5x gives the 25. But really, where do we get the negative 10x from? Multiplying x times negative 5 and negative 5 times x kind of make that middle term. Okay, maybe it's a little clearer to see in the next one. Okay, so if I look at 9x squared plus 12x plus 4, okay, perfect square, perfect square. So this is 3x times 3x. Okay, this is 2 times 2. And if I multiply 3x times 2x, that gives me 6x, and 3x times 2x. So if I, that middle term is the sum of the perfect squares of both of these kind of put together, okay? So I know this is a little harder to see. Oh, I wish I was with you guys in class so I could ask you some questions. Okay, so if I look at this, like what's the square root of that? Okay, so 2x times 2x, and 25 is 5 times 5. If I go ahead and multiply 5 times 2x, that gives me 10x. And 5 times 2x, that also gives me 10x. It's going to make that 20x in the middle. Okay, so how could I recognize them, that it's a perfect square trinomial? Okay, so let's look at this one. I would have to, the first thing would have to be a perfect square. Let's say 4x squared, okay? The last term would also have to be a perfect square. Let's say 49, okay? So both perfect squares here. And let's see. So then this could either be a minus or a plus, okay? So it will actually work both ways. It'll just sort of adjust that number in the middle. If I think about 4x squared, that's 2x times 2x. And 49 is 7 times 7, okay? Oh, sorry. Ooh, that has to be a plus sign back here. Oh, sorry, I said that. So 7 times 7, or negative 7 times negative 7. So if I multiply 2x times 7x, that gives me 14x. 2x times 7x, that gives me another 14x. If I add that together, the middle term would have to be plus 28x. Okay? The middle term could also be, those were negative, could be negative 28x. So you'd have to have a perfect square here and here, okay? And the middle term would have to be a combination of the square root of both of those kind of multiplied together, okay? So that being said, what do you think that factors into? Okay, this would factor into 2x minus 7 times 2x minus 7, okay? All right, so I'm going to give you a couple. Well, let's just do one more before we kind of move on. So I'm going to put another perfect square in the top. Okay, so let's say I have 16x squared and another perfect square back at the end. Well, let's just do 1 because sometimes people forget that 1 is also a perfect square. Okay, again, I got to have a plus sign here. Okay, I got to have a plus sign there. And what does 16x squared, what could that be? So 4x and 4x. I take the square root of 16x squared. And 1 is either 1 and 1, or it could be negative 1 and negative 1. So this would be a perfect square trinomial if the middle term were 8x, okay, or 8x. And then it would factor into 4x plus 1 times 4x plus 1, okay? So I've got perfect square, and then square root of the perfect squares multiplied together and then doubled, making the middle term. Okay, now if these were negative, then it would still work, except for this would be a negative 8x. And over here, these would both be negatives. Okay, so then the last grouping you should have seen were the ones that just were sort of other trinomials. So if you did E, I, and B together, there wasn't any special pattern in them. This wasn't a perfect square, although that was. Okay, so you really just kind of had to factor them regularly. And then if you looked at x squared minus 4, that was the one that actually doesn't factor. Okay, and you might think, wait, isn't that two perfect squares? It is, yes. Okay, but it's not a difference of two perfect squares. Okay, and there was no middle term, so it couldn't be a perfect square trinomial. Okay, you guys, this is a pretty hard concept. I'm going to give you a couple of problems, and I want you to see if you can recognize if it's one of the factoring patterns, okay? So here's the first one. So 25x squared minus 1. And again, and these are just shortcuts. Like, you don't have to use a shortcut. You could still make the generic rectangle and the diamond. It's going to work out great. But if you see this, instead of doing this, you could just do a shortcut. So I'm thinking, okay, my two shortcuts are difference of two squares. So if I see two perfect squares and I subtract them, that's one. Okay, or my perfect square trinomial, that happens, it's got to be three terms. These have to be perfect squares on the end, and then the middle term has to be, if you take the square root of both of those, multiply those two square roots together, and then double it, that's got to be the middle term. Okay, so is this going to be a quick factoring pattern? I hope you said yes. And it factors into perfect square. It's going to factor into 5x minus 1 times 5x plus 1. Okay, so let's try this one. How about x squared minus 5x minus 36? Okay, let's see. Do you think this is one of the two special patterns? Okay. Oops, hopefully you said no, because do you see a minus sign here? Okay, if there's a minus sign here, not a plus sign, okay, it is not a perfect square trinomial. You have to have a plus sign here, okay? So for that one, you would just have to use the diamond problem and factor it regularly. Okay, how about this one? X squared plus 8x plus 16. Does that fit any special pattern? Well, it's definitely not a difference of two squares. Is it a perfect square trinomial? Is that a perfect square? Yep. Sense x. Oops. Is this a perfect square? Okay, or it could also be negative. And when I multiply those together and double it, do I get the middle term? Yes, I do. Okay, so it must be a perfect square trinomial. So it factors into 4x plus, x plus 4, sorry, times x plus 4, or x plus 4 squared. Okay. All right. How about 9x squared minus 12x plus 4? Okay, so let's see. Is that a perfect square? Yep, perfect square. And is there a plus sign here? Yep. Okay, so, and let's see. If I do, this is 3x and 3x, and this is 2 and 2. Or, remember, it could be negative 2 and negative 2. Those multiply to give us 4. And when I multiply those and then double it, do I get that in the middle? Yes, I do. So this would be 3x minus 2 times 3x minus 2, or 3x minus 2 squared. Okay, how about 9x squared plus 4? Does that fit one of our shortcuts? Hopefully you weren't tricked by this one, because this is a perfect square and this is a perfect square, but it's not a difference of two perfect squares, okay? So if you wanted to try and see if it's factorable, you would have to try and use the generic rectangle thing, but you're going to find out it's not going to factor. Okay, so how about 9x squared minus 100? Okay, perfect square? Yep. Perfect square? Yep. Subtraction? Yep. Okay, what's it going to factor into then? 3x and 10. Difference of two squares. Okay, it's going to be 3x minus 10 and 3x plus 10. Okay, all right, would be that factoring pattern. Okay, so that's kind of it for the lesson. And again, remember, you don't have to memorize the shortcuts, okay? It's just kind of a quick thing if that helps you. If you're like, I'm not exactly sure if it's a shortcut or not, just work it out, okay? So go ahead and do your 9x squared minus 100. Do your diamond. It's going to work, and you're going to get your 3x minus 10 and your 3x plus 10. It's just a shortcut that you could use so you don't have to do this whole process, okay? Just playing around with some things. So if you want a little bit more on that, if you look in your book at question number 47, it kind of goes over it. If you Google probably any kind of lesson on difference of two squares or perfect square trinomials, I'm sure the Khan Academy has a couple of more examples for you. So, okay. Have a great day.